Welcome, geometry students, to the homework help video. Page 51, 2 through 6, 10, 11, and page 52, numbers 3 and 8 through 16. Let's go ahead and start on page 51, numbers 2 through 6. Now, this is kind of a little weird, interesting problem here. If you look at the directions for numbers 2 through 6, it says the letters of the alphabet have been sorted into 5 groups. What attributes were used to sort the groups? The letters at the right, let me pause and say now, your book should be open to page 51. So if your books are not open to page 51, it's going to be really hard to understand the directions. So please turn your books to page 51. Now, having said that, it says the letters at the right have not been placed in a group. Now that means these letters right here. So please look at the screen. These letters right here have not been placed in a group. Right there, K, L, M, N, O. And the question is, where does each go? Then it gives you a hint. It says consider symmetry. Okay, so this is a really good problem. I mean, it's a great thinking problem, but it's tough. It's a little confusing. So really pay attention and think here. Okay, let's take a look at this first group. When I look at B, C, D, and E, I realize a couple things. They do have horizontal line symmetry. For example, here's what I mean. If I were to draw a line right here through B and fold B on that line, the bottom half would fall right on top of the top part. And if I were to draw a horizontal line through C, same thing would happen in D and E. So all 4 of these figures have horizontal line symmetry. Notice though, they do not have vertical line symmetry. E, if you were to fold the E on that red line, you would not have one side falling exactly on top of another side. And so letters B, C, D, and E all have horizontal line symmetry. And so I'm going to come over here and look at K, L, M, N, O. Let me pause and say one more thing about B, C, D, and E. They do not have vertical line symmetry. So I'm going to put an X through it, okay? So I'm looking for a letter over here that has horizontal line symmetry, but does not have vertical line symmetry, okay? Now, L does not have horizontal symmetry. M does not have horizontal symmetry. N does not have horizontal line symmetry. O does, and so does K. However, please listen carefully. O also has vertical line symmetry, and K does not. So K is the only letter out of these 5 letters that has horizontal line symmetry, but no vertical line symmetry. Okay, so the missing letter here is going to be K. All right, let's continue on. Now let's take a look at group number 3 here. H definitely has horizontal line symmetry and vertical line symmetry. I definitely has vertical line symmetry and horizontal line symmetry. X definitely has horizontal line symmetry and vertical line symmetry. So I just went through these letters with you a second ago, and I said this one has no horizontal, and no horizontal. And this one here has horizontal but no vertical. So O's the one. Remember, O is the one that has horizontal line symmetry and vertical line symmetry. Okay, so the answer to number 3 would be, did not mean to do that, and I guess I could unveil the answer like this, I suppose. 3 would be O, and then for 2, as we already said, 2 was K. Now let's take a look at number 4. Now 4 is in a weird place. It's way down here. Okay, everybody see 4? All right, so let's take a look at number 4. Now, definitely no horizontal line symmetry here, nor here, nor here, but definitely vertical lines. So far, horizontal line symmetry, no. Vertical works here, vertical works here, it works here, it works here, it works here, and it works here. So these letters have vertical symmetry, but they does not have horizontal symmetry, okay? Well, I've already used K. I've already used O. And as I look at these last letters left over, this does not have vertical line symmetry. This one here does not. Be careful. This one here, if you have an N, it does not have vertical line symmetry. Okay, if you were to fold it over, it would not fall. This left side here would not fall right on top of the right side at all. So there's no vertical symmetry here, so it is going to have to be the letter M for number 4, because we do have vertical line symmetry right here for letter M. Okay, so far we've used K, M, and O. All right, so K, M, and O. Let's move on to number 5. Now, if you'll notice, all of these, they have no symmetry at all. They have no vertical, no horizontal, and they have no rotational symmetry either. They don't, okay? So we're looking for a letter over here that has no vertical symmetry, no horizontal line symmetry, and also no rotational symmetry. And that would be the letter L. Okay, let me show you very quickly. Okay, there we go. Now, rotational symmetry, remember we turn it 180 degrees, so we go from here to here. And if any time during that rotation it looks identical to this figure over here, then we have rotational symmetry. Well, as I start to turn it, nothing, 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 it never matches. So it does not have rotational symmetry. There's definitely no vertical line symmetry, and there's definitely no horizontal line symmetry. So L is the one that's going to go with this section right here, because none of these letters in number 5 here have vertical line symmetry, horizontal line symmetry, or rotational symmetry. Now, we can use the process of elimination for number 6, but I really don't want to do that. I want to explain to you what's going on for number 6. These two letters do not have vertical line symmetry nor horizontal line symmetry, okay? Actually, Z here would have, no, it would not have vertical line symmetry, and it would not have horizontal line symmetry. So the only thing they might have would be rotational symmetry. So we're going to find out right now, okay? We're going to take this S, and we're going to slowly turn it around and see if it ever looks like the left side from here all the way to here. Yep, there it is, 180 degrees. So S does have rotational symmetry. Now I'm going to check out Z. And you're going to see as you turn Z, it does have rotational symmetry. And so in number 6, these two letters have rotational symmetry. And guess what? But listen, S and Z have no vertical line symmetry, and they have no horizontal line symmetry. And that's the same thing with the letter N. The letter N has no horizontal line symmetry. It does not. It has no vertical line symmetry, excuse me. It has no horizontal lines symmetry. And it does have, however, it does have rotational symmetry. And watch carefully. If I take this N and rotate it right there, it looks just like this side over here. So N definitely goes in this group here. Okay, this was a pretty tough, confusing exercise here, but it was still really good to do. Okay, it's really drilling into you guys the horizontal and the vertical line symmetry, and also rotational symmetry. Okay, let's take a look at numbers 10, 11. Now the directions for 10, 11 read, sketch the pair of lines. decide whether the lines are parallel, perpendicular, or neither. Now I'm not really concerned with your sketching these lines. It's not a big deal to me. However, I do want to make sure that you're able to look at linear equations and look at each line's slope and make sure you know whether or not the two lines are parallel or perpendicular or neither. So when you look at the first linear equation here, notice y is all by itself. And the same thing with the second equation, y is all by itself. Now, anytime that y is by itself in a linear equation, the coefficient of your x is always going to be your slope. So for this top linear equation, your slope is 2/3. For this bottom linear equation, your slope is a negative 2/3. Now, we know for sure these two lines are not parallel because parallel lines have to have identical slopes, okay? Negative 3/2, excuse me. And so we know they have to have identical slopes. However, they might be perpendicular. There's two things that must take place for these two lines to be perpendicular. First of all, the slopes must have opposite signs, and they do. Secondly, the slopes must be reciprocals of each other, and they are. The reciprocal of 2/3 is 3/2, or you could say the reciprocal of 3/2 is 2/3. So these two lines are perpendicular. Okay, moving on to number 11. We have two linear equations. Notice y is isolated or all by itself in both equations. So we know the x coefficient is your slope. So the slope of the top line is 2/3, and the slope of the bottom linear equation is 2/3. Well, anytime that two lines have exactly identical slopes, we know those two lines are parallel, and that's the symbol for parallel, okay? Or if you want to write it out, I have no problem with that. That's how you spell parallel, all right? Okay, moving on. Now on the next page, page number is 52, page number 53, and go ahead and turn over there if you're not there. We're going to take a look at number 3. Now at number 3 here, they want you to find the midpoint, okay? And don't forget the formula. Whenever you're finding the midpoint between 2 points on the coordinate plane, it's x plus x divided by 2, comma, y plus y divided by 2. So here we go. This is my x, this is my y, this is my x, and this is my y. And here we go. X plus x would be 3 plus 2 divided by 2, and y plus y would be negative 5 plus 7 divided by 2. Well, 3 plus 2 is 5. 5 over 2 would be 2.5. Negative 5 plus 7 is 2. 2 divided by 2 is 1. So this ordered pair right here is the point that lies directly in the middle between these 2 points right here. Okay? 5 over 2 and 1, or 2.5 comma 1. Okay, let's take a look now at numbers 8 and 9. The directions read, we are given these following points, A, B, C, and D. Consider all, emphasis on the word all, consider all line segments that have these points as endpoints. So what that means is I have to consider segment AB, segment AC, and segment AD. Segment AB, AC, AD. Then go to point B. I have to consider segment BC and segment BD. So BC and BD. Well, Mr. Hart, what about BA? We already said BA right here. We set it as AB. Segment AB is the same segment as segment BA. So we have segments AB, AC, AD. Then we go to point B and we say BC, BD. Then we go to point C and we say CD. So there, excuse me, there are all of the possible line segments that you can get out of these 4 points. All right? So what they're asking us in numbers 8 and 9 is to tell us which segments are parallel and which ones are perpendicular. So we're going to have to find the slope of all of these, okay? And don't forget, slope is, I'm going to write it real bigger, then I'm going to erase it. The slope formula is y minus y over x minus x, okay? Please don't forget that. So with that in mind, let me do that again, please. And with that in mind, here we go. So we're going to start off with points A and B. So y minus y, that's going to be 3 minus 2. here's your y, and here's your y. And then x minus x is negative 2 minus 1. So negative 2 minus 1 would give us 3 minus 2 is 1 over a negative 3, which gives you a negative 1/3, because a positive over a negative is a negative. So negative 1/3. Now AC. Okay, we're going to look at A and C. So here we go. Y minus y, that would be 3 minus a negative 2. And then x minus x would be negative 2 minus 3. And we would get 5 over negative 5. 3 minus a negative 2 is 5. Negative 2 minus 3 is a negative 5. And so a positive over a negative is a negative, and 5 over 5 is 1. Okay? Now let's go on to AD. Here's point A, and here's point D right here. Okay? Y minus y is going to be 3 minus 0. X minus x is going to be negative 2 minus a negative 3. So we would end up with 3 over 1, because 3 minus 0 is 3, negative 2 minus a negative 3 is 1, and 3 over 1 is just 3. Okay? Now let's go on to segment BC. So here's B and here's C. All right? So y minus y would be 2 minus a negative 2. 2 minus a negative 2. And then your x's would be 1 minus 3. 2 minus a negative 2 is 4, and 1 minus a negative 3 is negative 2. A positive over a negative is negative, and 4 over 2 is 2. And then BD, so we're looking at B and D. So y minus y, let's go ahead and put some dividers up here real quick so it's not so confusing. And now let's consider on. Let's move on. Let's take a look here. Y minus y, we would have, or excuse me, BD. So we'd have 2 minus 0, and then x minus x is 1 minus a negative 3. 2 minus 0 is 2. 1 minus a negative 3 would be 1 plus 3, which is 4, and 2 over 4 reduces to 1/2. Okay. And now let's come over here and let's find the slope of CD. So C and D. All right. Y minus y would be negative 2 minus 0. X minus x would be 3 minus a negative 3. So negative 2 minus 0 is negative 2. 3 minus a negative 3 would be 3 plus 3, which is 6. A negative over a positive is negative, and 2 over 6 is 1/3. There we go. So there's all of the slopes. Okay. Now let's go ahead and grab this. Pull it over here. Let's get rid of these points and pull them over here. Now they want us to decide which lines are parallel and which lines are perpendicular. Well, first of all, if I have parallel lines, I'm going to have identical slopes. The only identical slopes I see would be this one here, negative 1/3, and this one here, negative 1/3. So I know for sure that AB is parallel to CD. Okay. That's for sure. So the answer to, let me actually pull this back up here real quick if I can. There we go. Okay. Which line segment is parallel to AB? Well, CD, because the slope of AB is 1/3 and the slope of CD is 1/3. Now question number 9, which line segment is perpendicular to AB? All right, well here's AB, negative 1/3. Now if you're looking for a line that's perpendicular, you're looking for a slope that has a different sign, so it's got to be a positive slope, because look, they're asking for which line segment is perpendicular to AB. The slope of AB is negative 1/3. So the slope I'm looking for has to be a positive slope. So this line segment here is out because it's negative. This one here is out because it's negative. And this one here is out because it's negative. So if the slope of AB is negative, the perpendicular slope that I'm looking for is positive. So this is positive and this is positive. Now I'm looking for a slope that is a reciprocal of 1/3. Well, if I flip 1/3, I'm not going to get 1/2. If I flip 1/3, I'm going to get 3. And so AB is perpendicular to AD. So the answer to number 9 is AD. Okay? So again, we're using slopes to compare lines and see which ones are parallel and perpendicular. Now, this problem here is pretty difficult, so please pay attention. It's not easy to see, but I'll try to help you. Which labeled plane is perpendicular to plane A? Well, here's plane A right here. I'm going to highlight it for you. Okay? There we go. Plane A. It's a flat surface right there. Now, let me show you something. Do you see this plane right here? Plane C? In order for plane C to be perpendicular to plane A, they have to form a right angle, okay? Think of a shelf, okay? I'm not a very good artist, and you guys know that, but if you have a shelf here, and then, of course, this is the wall it's connected to, you know that you have a 90-degree angle there because the shelf comes over and then the side of the shelf goes up like this, and that's 90 degrees, okay? And so that's what they're referring to when they say, are the planes perpendicular? Well, there's no way, if you'll look carefully here, there's no way that plane A and plane C, there's no way one is exactly flat this way and the other one's going straight up like this. It's just not happening, and neither is plane A with this plane over here. They don't form a right angle at all, okay? However, this plane right here, this top plane B, this whole flat surface up here, it's going straight across, and this plane is going straight down. So plane B and plane A are forming a right angle right there. So which plane is perpendicular to plane A? It's going to be plane B. Plane B. It's difficult to see, but it's going to be plane B. All right? Now, question number 11 says, which line is perpendicular to plane B? So in other words, if you have plane B, which is right here, if I can get my pen to work here, hold on one second. Here's plane B, this whole flat surface right here. There are many lines coming off of plane B that are perpendicular. This line comes straight down. This line comes straight down. This line comes straight down. All of those lines are perpendicular to plane B, and perpendicular would be like this. If you had a sheet of paper like this and you took a pencil and you stuck a pencil straight through it right here so that it went through the sheet of paper, okay, and that pencil's going straight up and down, that line right there is perpendicular to the plane, okay? And so it's the same thing over here. This line right here is going straight up and down. It's perpendicular to plane B. So the line that's labeled that's perpendicular to line B would be line M. Line M right here is perpendicular to plane B. Okay? All right, one more problem and we're finished with this part of the homework assignment. Actually, that's not correct. We have actually 5 more. Sorry about that. Okay, so here we go. Let's take a look at numbers 12 and 13. Now, in numbers 12 and 13, you are asked to find the area and the perimeter. And so very quickly, starting here, I can find the perimeter. Starting here, I don't count where I put my pen, but starting here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20. So there's 20 units going around this object. So the perimeter is 20 units. Okay? Now, the area, well, remember, every time you have 4 dots, you form a square. And I'm not going to draw all these squares for you, but we can count the squares. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And so the area is going to be, now be careful, it's going to be 19 square units. Okay. All right, let's find the perimeter of this figure over here. Putting your pencil here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the perimeter is going to be 16. Now the area is going to be 1, 2, 3, 4, 5, 6, 7, 8. So the area is going to be 8 square units. All right, moving on to number 14. Starting right here, I'm going to count the distance around for the perimeter. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 29, 30, 31, 32, 33, 34, 35, 36. So I'm getting a perimeter of 36. Now let's count the area real quick, the boxes, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm getting an area of 17 square units, okay? Now this circle is going to be a little different. You understand it's going to be really hard to try to count around the circle because you're not using straight lines. It's going to be hard to find the area too. So what we have to do is we have to remember how to find the circumference or perimeter is 2 pi r, and the area of a circle is pi r squared. Okay, now let's go ahead and find the radius. Here's the center of the circle, obviously, so we'll go straight out to the edge. There we go. So starting here, let's count the units for the radius. The radius is 1, 2, 3. So the radius is 3. Now, is it 3 inches or 3 yards or 3 meters or 3 feet? We don't know. And it really doesn't matter as long as we know we just have 3 units for our radius. So my radius equals 3. Now, let's come down here and let's find the circumference or the perimeter around the circle. So it's 2 times pi times 3. Radius is 3. Now, I don't care if you write your answer in terms of pi or if you use a decimal, but let's know how to do it both ways, okay? If you write your answer in terms of pi, you're going to leave it 6 pi. And the reason for that is because you have 2 times 3, 2 times 3, which gives you 6, and then bring your pi down. And that's a fine answer. If you want a decimal answer, then you would take 6 times 3.14. You would put 3.14 for pi, and you would get what? 24, carry your 2, 18, 18.84. Okay? So there's the circumference. Now the area of the circle is going to be pi, and then r, and then squared. So if I asked you to write your answer in terms of pi, well, 3 times 3 is 9. You would simply write 9 pi, and that's your answer. But if I asked you to give me a decimal answer, then you would take 9 times 3.14, and your answer would be, let's see, 36, carry your 3, 2, carry your 1, 28.26 square units, okay? So be very familiar with these two formulas. This is a circumference formula, and this is an area formula. All right, let's move on to number 16. Okay, students, on number 16, the problem reads as follows. You are buying shingles for a roof. Each bundle of shingles will cover 27 square feet. So I'm going to very quickly stop, and I'm going to put a bundle right here. Here's a bundle of shingles, and they're going to cover 27 square feet. Okay, let's continue on. The roof consists of 2 rectangular shapes. Each one is 70 by 30. How many bundles of shingles do you need? Now, obviously, if you'll think about it, I have no idea how many bundles of shingles I need until I know how many total square feet that I have. Because look, bundles are not necessarily measured in square feet, but, sorry students for that interruption, bundles are measured in 27 square feet. So every time you have 27 square feet, then you know you need one bundle. So the only way to know how many total bundles that you need is to find your total square feet. So it says here in the problem that your roof consists of two rectangular parts. So here's one rectangular part, and of course it's 70 by 30. Here's the other rectangular part, and of course it's 70 by 30. So the feet, of course, feet, 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 and feet. So 30 times 70 would give you 2,100 square feet, and 30 times 70 would give you 2,100 square feet. So if you add those two together, your total square feet that you need is 4,200 square feet. Okay? Now, every 27 square feet that I have, I need a bundle. So I'm going to take 4,200 and divide it by 27. And if you do that correctly, you're going to get 155.5. Now, there's no way you can buy half of a bundle, so you're going to have to buy, excuse me, 156 bundles. Okay? 156 bundles. All right, so I hope this homework help video has been a help. If you have any questions, don't hesitate to call or email.